Through the use of a Hubble Space Telescope photograph, astronomers reported the finding of the furthest known star in March 2022. The Old English term for morning star was Earendel, therefore they called it after that. The same star has now been examined by JWST's NIR spectrometer and near-infrared camera, which has provided new information about it. It looks that Earendel is a large B-type star. That places it evolutionarily on the main sequence, indicating that it is a hydrogen-burning star. It is 1,000,000 times more bright and twice as hot as the Sun. Astronomers believe that this star, like several other similarly massive stars, may have a partner. However, because they are so close to one another, and we are viewing them from such a distance, it is difficult to distinguish between them. But this star's spectra gives some indication that a companion could be there. They should be able to identify the companion with the aid of more research utilizing the gravitational lens's magnification and more in-depth images made with JWST's NIR cam. Only 900 million years after the Big Bang, the star Earendel began to radiate the light we see today. The gravitational lens that made it visible is 4,000 times more magnifying Earendel. Now, scientists are interested in learning if it belongs to the very first star-forming generations. If true, its spectra would show that it is mostly composed of hydrogen and helium. If it is a second-generation star, its light's characteristics would also reveal more components. Rigel and Beta Centauri are two further instances of this kind of blue supergiant star. We see the host galaxy of this star as a lengthy streak of light in the form of a crescent. Gravitational lensing from the large galaxy cluster JWST 0100 and 3708 is to blame for the smearing. This far-off galaxy is seen in great clarity in the NIR cam image. There are nurseries where the stars of tomorrow are being born. Some of those stars are just 5 million years old, making them relatively young. Star clusters that are far advanced in their evolution can also be found in the galaxy. One of the clusters has a lifespan of around 10 million years. It may still be around in the present-day universe. The cluster provides scientists with some intriguing hints on the globular clusters that now abound in our own Milky Way. It is possible that some of them developed at the same time as the distant clusters in JWST 0100 and 3708. It's interesting to note that the JWST image provides more information regarding the lensing effect on the far-off galaxy. The town of Earendel is situated along a lensing-created ripple. That is how it looks when it is not included in the distorted picture of its home galaxy. NIR cam captured this picture, and JWST's infrared spectrometer also recorded data. It provides scientists with further information regarding the precise separation between Earendel and its host galaxy. Using its infrared-sensitive equipment, JWST has discovered more far-off stars. Earendel continues to hold the distance record, but there are still a lot of other things to notice. Astronomers are working toward one of their ultimate goals, locating the very first stars to ever light. Those very first things could have materialized as soon as 100 million years after the Big Bang. They were probably quite large and incredibly bright. They heated and ionized the atmosphere surrounding them as they emerged from the cosmic dark ages. In their hydrogen-burning cores, they created heavier chemical elements as they grew and perished. When they perished, they dispersed those components throughout space, where they eventually seeded planets and future star generations. We shall learn a lot about all those circumstances in the young universe, the dispersion of matter, and the eventual development of galaxies in the early epochs of cosmic time from the evidence of their lives and lifestyles.